Typical Nerf guns are just super weak. You can't even reach the target with them. Who wants to pay $50 for something like that? That is why I'm going to make something that can actually launch the darts. This is a basic diagram of how the magazine system is going to work. So in the middle right here, I have the magazine itself. The magazine needs to be able to push the darts up. And this is going to be accomplished with simple rubber bands. The rubber bands are going to be stretched from this mounting point over this pulley wheel and then attached over here to this mounting point. Just like this. And this is going to be the same for both sides. The reason I need the rubber bands to be stretched over the top of the pulleys instead of just being connected at the top, stretched down and connected to the slider piece at the bottom, that is because I need this slider piece that moves up to be able to go all the way to the top. To begin the magazine, I cut 2 square pieces of plastic that will go on the sides. I 3D printed the edges for convenience. In order to connect the edges with the side pieces, I'm going to drill holes and screw them together with M3 screws. I'm also going to need a plastic pusher thing that will push the darts up, and 2 pieces of plastic on top to keep them from flying out. It was pretty easy to assemble the whole thing together. In order to push the darts up, I'm going to use this rubbery stringy thing. The ends of the string will be tied at the bottom, go over the pulley, and then attach to the slider moving thing. It was kind of hard for the darts to move up the chute, so I 3D printed these things that will help guide them. There's a problem though. Because the pulleys are just straight pieces of plastic, it gets stuck, and this is bad. So I 3D printed pulleys that are really shaped like pulleys. This will help center the rubber band in the middle. Yes, that is much better now. You can push the darts in and they don't fall out. But unfortunately, only one stays in. In order to fix this, I'm going to 3D print different holders. And after that, they fit like a charm. The pusher mechanism will be able to push them out. Before we start making the gun itself, we need to know how the launching mechanism is going to work. It might seem complex at first, but it's actually not. Right here we have 2 flywheels which are going to be spinning in opposite directions. One is going to be going counterclockwise and the other is going to be going clockwise. The magazine sits right underneath the pusher belt system and the darts are ready to go. When the belt system starts spinning in a counterclockwise direction, the darts will get pushed towards the flywheels, and those flywheels will accelerate it super fast out of the end of the gun. These 2 flywheels are going to be operated by 2 motors. This is how the launching mechanism is going to work. The main electronics that I'm going to use are going to be 2 38 brushless ESCs, 2 2700 kV motors, 2 LiPo batteries, and the Arduino Uno R3. Here I have all of the big electronics that I will need to make the gun. I have my Arduino Uno R3, which is the controller board, and then these 2 brushless 30 amp motor controllers, and these are the 2 motors. I mounted them to a piece of wood so that I could test them safely without them flying all over the place. And then 2 of these batteries one battery will power each motor. And now I'm going to code up some code and see how I can get this to work. This is the code that I wrote to run on the Arduino. I want to be able to control the speed of the motors, and so I wired up this potentiometer that I will use to control the speed. Wiring all of it together was pretty easy. One of the batteries is going to power one of the motors, and the other is going to power the other motor and the Arduino, because the Arduino needs power in order to tell the ESCs how fast to spin the motors. The motor is quite fast and I was surprised at first. Let's try it with both of the batteries. We need to make sure that the motors are spinning the opposite direction from each other, otherwise the darts will not launch. I'm going to arrange everything on the table to see how much space it will take inside the gun, and from that I will know how big to cut the sides. I'm going to 3D print this motor mount, but PLA is simply not strong enough for this. So, I bought some PETG. I have never used PETG before, but it should be better. PETG is more heat resistant than PLA and it also can withstand more force. It suits my needs a lot better. I'm going to cut this rubber band into a few squares and punch holes through the middle. I will put them in between the motor and the mount so that it will dampen some of the vibrations and the noise. Everything is going to be screwed together with some M3 bolts and nuts. The reason the motors are going to be mounted at 10 degrees angle from each other is so that the dart will spin through the air and that will cause it to be more stable in its flight. I'm cutting these rectangles so that I can stick the motor mount through them and screw it together. I had problems figuring out how big it was, so I constantly had to adjust. The flywheels are also going to be printed out of PETG because I feel like PLA will just rip apart at those RPMs. The dart snugly fits in between them. You can see how it rotates as it moves. 3D printing this part wasn't ideal because of the layer lines. I could have printed it on its side, but I didn't think of that at that time, so I guess I'm just stuck with this. I'm still going to use PVC pipe for the end because it's a lot smoother than 3D printed plastic. I decided to print the other side out of PLA as it is just a cover and it will not be taking any forces. I also 3D printed these spacers to go in between to keep it all nice and straight. In the end, I was very surprised how strong this thing came out. Okay, I'm done making all of this stuff, which is the main system for how the gun is going to launch the darts. It is time to test it. I'm very excited for this and I hope you are too. I'm going to now stick the batteries into the ESCs to power them. The motors are doing their thing. Okay. Okay, there we go. Okay, it works. Wow, that's pretty loud. Okay, I control the speed with this potentiometer right here. Spin it more or less. I'm gonna try a few different power settings. I have this bag of darts, which is what I'm gonna use, so let's do it. That was only a tiny fraction of how powerful this thing is. Okay, that was some pretty serious power there. Whoever made it to the end of this video, thank you very much. If you like my videos, please consider liking and subscribing. It really helps me out. And I hope you're looking forward to part 2. It will be coming out around the end of July.